Saxon Algebra 2, Lesson 78. If you look at this lesson in the book, and I'm going to show you in a minute, you might faint. It looks so hard. It looks like some crazy physics problem that has wandered into our innocent little algebra book and created a monster storm of scary problems on your page. Even the name, force vectors, are you kidding me? That sounds really, really hard. So what I'm going to do is show you, but I'm going to tell you, don't worry. These are nowhere near as horrifying as they look. We're very quickly going to break this problem down into something that's quite familiar, and then it'll be very manageable. Look at what we've got here. Oh my gosh. It's a pulley with a rope going through it. This is a physics problem, you guys. And we're saying, it says two ropes are attached to a point and pulled on with different directions, with the directions and magnitudes shown. What is the resultant force on the point? Oh my gosh. Imagine you're on a sailboat, which is a place where there's lots of ropes and things being pulled. And this is attached to the deck, this pulley, right? And you know, a pulley, the rope feeds through it, but it's easy for the rope to move. It could slide this way or it could slide this way. It's going to stay going through this little piece of metal, but the pulley makes it easy for it to slide. So we pretend that there are two different people up out of the sight of this picture. There are two different people pulling on this force. Let's make it fun. Let's say this side we have a person pulling, and over here we have a monkey pulling. And when we start out the problem, there's a little piece of tape on the rope, right where the pulley is, right there. And we want to know, where's that little tape going to end up when the person pulls with 70 units of force at an angle of 45 degrees, and the little monkey is pulling at a 30-degree angle, but he's only got 40 units of force. Where's the little piece of tape going to end up? That's what we're trying to understand. The way that we do it is to break these two forces down into friendly triangles that we are used to, okay? Once we go from here to here, this problem is familiar. It's an old-fashioned piece of cake, all right? So let's look at how we go from this crazy picture with the monkey. Think Pirates of the Caribbean, that crazy little monkey. So what we do is we take this picture, this scary diagram, and we convert it into our triangles. Look, this is a second quadrant angle, right? If you imagine our grid here. This is at a 45-degree angle down here. So to measure the angle, we'd go like this, wouldn't we? But it's a 45-degree angle, and then it's got a distance of 70. So look, we have the angle and we have the hypotenuse. And then we do the same thing over here. This is like a first quadrant angle, isn't it? If you imagine that grid on here. 40-degree hypotenuse, or not 40 degrees, 40 units, doesn't tell us what, and a 30-degree angle. Now it's something very manageable. And what we can do is we can calculate rectangular coordinates, add them together, and then what we'll actually do is draw a triangle that shows where our little piece of tape will end up. Now, I will say this. If this guy is pulling with 70 pounds of force, and this little monkey's only got 40, I don't know if they're pounds, I made that up, 70 units of force, 40 units of force, I imagine that piece of tape is going to go this way, don't you? It's going to slide over here because this guy's stronger. So we'll see. But what I'm going to do is I'm not going to draw the ropey picture, and you don't need to draw it either. What I'm going to do, and I'm going to put them on one big thingy so you can see how that picture easily translates to our triangles. This is our 70, and that equals the hypotenuse, and this is 45 degrees, right? And then we have our little monkey side over here. This angle is just 30 degrees, and this is 40 units equals our h. Okay, so what we want to do is we want to convert, let me just write steps though. The first thing we do is we draw the triangles. And I'm going to show you once again. If you compare the triangle, the crazy rope picture in the book to what I drew, you'll see it's the same thing, right? I just imagined that the ropes are the hypotenuse and I drew the grid in. I put them together. I could have drawn them separately if I wanted, but I wanted you to see how we can just work off what the picture looks like, because you'll see here for the first practice problem, it's similar. So you'll draw these triangles just like we're drawing triangles right now, okay? So once we get it to this form, I hope you'll agree, oh, this actually isn't scary anymore because we're very used to dealing with triangles like this. So our next step is convert to rectangular coordinates. And then we will add them. Okay, now I'm using up a lot of my paper here with my notes. So what I'm going to do is I'm going to draw the box down here where I will fill in the information. This will be triangle 1. This will be triangle 2. So here for triangle 1, I'll have a number. I'll have a sign and a number for my right, and I'll have a sign and a number for my up. Then I'll do the same thing for triangle 2. A positive or negative sign. Whoops. I'm going to put the rights together, and then I'm going to put the ups together, and then I'm going to add them to get my total. Right? Okay, so how do we convert this to rectangulars? Oh yeah, we remember that this, which is this is our up axis, this is our right axis, right? Just different names for X and Y to try to confuse you. This measurement along the right axis, this will be the same as my adjacent side. This is my up value. That's the same as the opposite, right? Because we're measuring from here. Adjacent, opposite, and that's hypotenuse. And then over here, we'll do the same thing. This will be the right side, which is equal to the adjacent. This will be the up measurement. The up, we measure down here on the triangle, but we can copy it right over from here on the up axis, right? That number. This will be equal to the opposite. So when we go to do these, so here's triangle 1, we'll take, remember we can kind of shortcut this process now. We know that we want to do the right first. The right number will equal the hypotenuse times the cosine of the angle. And our up value, whoops, this is still the first triangle. The up value will equal 70 times the sine of 45 degrees. Remember that we're using the right trig function for the sides we're trying to compare. So down here where I'm finding the right value, that's the adjacent side. We're going to use hypotenuse as well. Adjacent over hypotenuse is cosine. So that's why I use cosine. Cosine always leads us to the right measure, and then to find the up angle, that's opposite. Opposite and hypotenuse give us sine. On the second triangle, the right value will be 40, the hypotenuse. Again, we'll use cosine. This time it's 30 degrees. And then the up value will be 40 times the sine of 30 degrees. Okay? This by now, I'm hoping, feels pretty familiar and comfortable to you, right? Remember, we don't even have to write the we don't have to write it in the old trig function standard. We can skip forward and cross multiply and bring that up, right? What we're using is cosine equals adjacent over hypotenuse, and we're using sine equals opposite over hypotenuse, but we're bringing that h up, and that's why we multiply by that. I'm hoping that looks familiar to you. Before we get our calculators, the other thing we can do is figure out the positive and negative values, because we don't need a calculator to calculate those. We just use common sense. On this triangle, remember this is the origin, this is the center. We see this right value is going to be negative, right? Because the negatives are over here, the positives are over here. So this is going to be a negative right and a positive up, right? Because it will be like this. So that's what the first triangle will be. The second triangle is a positive right and a positive up. So I can fill in the signs before I grab the calculator, which just makes it a little bit easier, maybe. I think so. Okay, so let's start cranking out our numbers, right? Use your calculator. Remember, we work backwards through the calculator. Enter the angle, hit the function, times the hypotenuse. 45 sine times 70. These are the regular trig function buttons on the first screen of your calculator. You don't have to use that second key for these. And the reason why is because in these, we know the size of the angle and we're trying to find one of the sides. Okay, we know the degrees. We use the inverse tangent, that -1 button, when we don't know the degrees and we're trying to figure them out. Okay. So 70 times the cosine of 45 degrees. I'm just going to write it right in this box. I'm not going to write the answer over here. I'm just going to put it right down here. This is 49.497. The sine, the 70 times the sine of 45 degrees, that is also 49.497. At first you look at that and go, wait, what? That doesn't seem right, but I'll tell you why we know it's right. A 45-degree angle is special because they'll be both 45, right? These guys have to add up to 90, and then with this one they add up to 180. So when you have 45-degree angles, cosine and sine will be the same. Good to know, right? Okay, then what about this? 40 times the cosine of 30 degrees is 34.64. And 40 times the sine of 30 degrees is a cool 20 even. So now we're ready to combine these. So these are moving in opposite directions, aren't they? So the difference is negative, and I'm going to round, 14.86 R, and then these work together, so it's plus 69 point, I don't know why I left that one with 3 decimal places. I'm just trying to mess with your head, I guess, right? Okay, so there's the answer to where our piece of tape is going to end up after the man and the monkey pull. Now, I'm guessing it's Captain Jack Sparrow pulling on the other side. Maybe it's Will, I don't know. I keep thinking about that. This is where the piece of tape ends up. But what we want to do is we want to draw a picture of that. No. Yes, we do. We do. John wants us to find, he calls it the resultant force. Well, in order to find what's the force, we have to write it as a polar vector. Shoot. Okay, let's turn the page. We can do it. It's not hard. We've been doing this over and over, right? We take the points, we turn them into rectangular points, we add them, and then we change them back into polars. We've been slaving over this. All right, our point is minus 14.86 R plus 69.497 up. Okay, that's our resultant force in rectangular coordinates. Let me just make sure I copied it right. It's this number, right? Okay, now we have to draw this triangle. Okay, minus right, positive up. Okay, that means it's going to be in the second quadrant. And I'm not going to draw it to scale, but I can see it's just a little bit this way, and it's a lot this way. I draw my point where the two intersect, and then I connect back to the origin and this axis, the right axis or the x-axis, if it's still, you think of it that way in your head. All right, now we know that this distance is 14.86. We don't have to say negative because the length of that piece of the triangle is a positive number, right? Even though it goes to the negative side of the origin, that's a positive number. And this, even though we originally measured it over here on the up axis, we know that this side of the triangle is 69.497. Now, we want to rewrite this triangle as a polar coordinate or a force vector. You can call this a force vector. Whoa, sounds pretty smart, right? And that's what it is. It's just like the physics version of, in math, we say polar coordinates. In physics, we say force vector, okay? So it's a fancy name for this kind of answer. So now we're faced with a situation where we need to take this pair of sides and we need to use it to find first this angle, then this angle, right? Because the number that goes here is how far you need to go from the horizon, if you will, to where the triangle's hypotenuse begins, right? We have to think about the person who's going to look at this number and try to recreate this triangle. We don't want to tell them this. We want to tell them this. Okay? But first we'll find this out, and then we'll figure out how to tweak it. And then we also have to find out the hypotenuse, because that will tell them how far to go out in order to find the point. All right. Now, there are two ways to find the hypotenuse. We can use Pythagorean theorem. And this is Pythagorean theorem just rearranged a little bit so that we can put these values in and calculate. That's absolutely fine. All right. There's another way to do it, and I'm going to show you that way after we've found the angle. Okay, to find the angle, we know we want to use tangent because this is the opposite and this is the adjacent. The tangent of theta, whatever this angle is, we don't know the degrees. It's going to equal the opposite, 69.497, over the adjacent. Okay, so we grab a calculator. We enter 69.497 divided by 14.86 equals. That gives us a decimal number. Then, with that number still alive in the calculator, we go to second. So first we divide. Then we go to second, and then we go to tangent of -1. Remember, that's the calculator's way of saying, you've given me the decimal number, I'll give you the degrees. So these are the 3 steps for entering this into the calculator, and what we get is that theta, the measure of this angle, is 77.93 degrees. All right? Okay, cool. So now what we can do is we can figure out, okay, what number needs to go in here? If this is 77.93, then what number goes here? And we can see, oh, look, this whole thing would be 180 degrees. So if we want this part, we take 180 and we subtract this angle. So we take 180.00 and we subtract 77.93. That's this part of the angle. And our answer is 102.07. And that's what goes up here. And we can double check it using logic. This would tell us that if we're starting here, we need to go 90, and then we need to go another 12 degrees. And we see, yeah, that's right, because then this is almost 78, right? I'm rounding the decimals off just to double think it. That makes sense. That 102 is how far I need to go just to get to right there. Okay, beautiful. So now we've figured out the angle business. Now, what I like to do is remind you that we can find the hypotenuse another way. Now that we know this angle, we could use this angle with this side using sine, or we could use this side using cosine to find it. Let's use this number, cosine. I'm going to slide up just a little bit. We know that cosine of any angle equals adjacent over hypotenuse. So the cosine of our angle, which is 77.93, equals the adjacent 14.86 over the hypotenuse. That's another way to solve for the hypotenuse. We can use that Pythagorean theorem, but once we get the angle, we can also use sine or cosine with the angle that we calculated, 77.93 degrees. All right? So then we would have to, let me flip here, we would cross multiply these, so they'd both be up here. Let me show you. H times the cosine of 77.93 degrees equals 14.86. Yes. That's me cross multiplying. Then we're going to divide away this so that we have H by itself. Cosine of 77.93 degrees. That's gone. And we would say that H equals 14.86 over cosine of 77.93 degrees. So to do this on your calculator, which you certainly can do, this is not a hand calculation, we'd enter 14.86 divided by, open parentheses, 77.93 cosine, close parentheses, equal. And what you should get is that the hypotenuse equals 71.07. You take this number back to our original answer box. There is our final answer. So that masking tape, as I suspected, Captain Jack Sparrow is stronger than the monkey, and it went way up here. That piece of tape that was down here, it went all the way up here after those two had their tug of war. Captain Jack Sparrow won the battle of the force vectors. Okay? Woo! That was kind of a workout, wasn't it? That was a long problem. It was familiar once we got past the picture, right? Getting the picture was key. That is also true in this next problem. I want to start fresh. The next problem, and there are only two problems in this lesson. And this picture is smaller, so I'm going to copy it out of the book for you. Imagine you've got a rope tied to a cement block and you're dragging it. And first you're dragging it across the ground, even and flat, and then you have to, they call this a push force because you're just sliding it across, and then this is a pull force because you're pulling it up up a ramp. Okay, imagine that it's like a slide or a ramp. Where would you find a ramp like this? Maybe like a loading a van. You know how sometimes they have ramps that you would pull the box up? So it says here a point is acted on by a push force and a pull force as shown. Find the resultant force on the point. Oh, this is the point. And so first we're pushing it and then we're pulling it. Okay, so how do you combine that into two angles? All right, well, we're gonna have to draw triangles just like we did before. And the tricky thing is, let's call this part 1 and this part 2, just like we did last time. We'll make two triangles. This first triangle, we're gonna draw them separately this time. This first triangle is not really even a triangle. I'm gonna draw it as just a little bitty bit of a triangle so that we can imagine it that way. And what we can see is that it's going 10 degrees to the right, but it's not going up really at all, right? I made it look like it was going up a little bit, but it's just flat. So this first triangle, this first force is what I would call a flat force. That's a mathematical, that's my simplification of physics. It's a flat force. It doesn't lift it up at all, it just slides it across. It moves it 10 units to the right, but 0 units up. Oh, okay, that seemed like it was gonna be really hard, but it's not bad at all. Now let's do our second triangle, which is a little more conventional, isn't it? It's a first quadrant, baby. This is 30 degrees, this is 16 units, that's the hypotenuse. We convert this just the way that we always have, where we will take 16, the right value will be 16 times the cosine of 30 degrees, and the up value will be 16 times the sine of 30 degrees. Right is always associated with cosine, up is always associated with sine. We do that, and we find this number equals 13.86, and this number equals 8. Remember, we enter 30 cosine times 16, 30 sine times 16. So let's combine them right up here. There's no need to keep rewriting this. This will be plus 13.86 to the right, plus 8 up. So when we add them together, we get plus 8. Okay, this is our calculation that shows us where this point will end up after we push it and then pull it, right? John says something and I'm not sure that it's, no, I'm not even gonna say it. He's talking about the whole push versus pull and makes the point that it doesn't really matter, but we're just gonna ignore it because we know it doesn't matter. We're not even gonna talk about it. Okay, so this is the rectangular coordinate of the combined force, which is what we're always calculating. We don't always call it a force, but that's the combination of the two, right? Just like we did with Jack Sparrow and the monkey. Okay, now we need to find the quote-unquote resultant force, which simply means take this and rewrite it as a force vector, quote-unquote, right? Okay, so that means we need to draw this triangle. This I can see is going to be a first quadrant triangle because it's positive, positive. And I can see that my right value is bigger than my up value, right? It's like 3 times bigger. That's the beautiful thing about these triangles is we do not have to be proportionate. I put in, this is gonna be my 23.86 right here. And this is gonna be my 8 up. I go to where these two intersect and I put a dot. Then I reconnect from the origin to my dot, and then I go back to the right axis. Remember, our triangles are always grounded to the right. It's just how trig works. This side I know is 8. We measure it over here first, but I don't like to write it over here because I'd rather have it closer to that side of the triangle. Okay, so now what we need in order to write this little puppy as a force vector, I always like to imagine what my answers are going to look like because it's easy to get turned around. Oh yeah, it's going to be like this, right? This is going to be my force vector. If I wanted, I could write combined force in rectangular coordinates. And this is the combined force as a force vector. I don't want to write all that though. Okay, so we're doing what we did last time. We are now switching this back. We're going to need to know this angle, and we're going to need to know the hypotenuse. Again, we can use the Pythagorean theorem to get this. That works perfectly fine. I'll give you that formula again. It equals, I just say a squared plus b squared, but it's these two numbers, right? Square root of. That's one way to do it. The other way is to use either sine or cosine with this degree, once I get the degree figured out. So let's work on the degree. The degree, we always know that it's tangent that we're going to use. Tangent equals opposite over adjacent, right? Over Arthur. So it's going to be 8 over 23.86, right? Over Arthur. We enter this into the calculator by doing 8 divided by 23.86. That gives us a decimal number. Then we do second and tangent to the -1. And that will tell us that our angle equals 18.54 degrees. This is a first quadrant angle. Yay, that means the degrees are just the degrees. We don't have to do anything fancy, right? This is exactly the angle we want in here. So I write 18.54 degrees in here. Now, to find the hypotenuse, I'm going to use this angle, and I think I'll use the opposite side. So I'll use sine, and I will say that the sine of 18.54 degrees equals the opposite side, which is 8, over the hypotenuse. To solve this, I have to cross multiply and then divide, and it will end up being, I'll go to the next page. The sine of 18.54 equals 8 over h. That's what I had on the last page. Remember, we cross multiply that up and then divide this chunk away, and it'll always come out like this. This is kind of a mouthful to run through the calculators. 8 divided by parentheses 18.54 sine, close parentheses, equals. And the value that we get is h equals 25.17. I don't think I've said this in a while, but please, by all means, grab your calculator as I'm walking you through these calculations. Pause me if need be. Make sure you can do them. Now's the time to practice, right? Okay, 25.17 goes in our answer box right here. That's the hypotenuse. Remember, this is the hypotenuse, and this is the degrees. Sometimes it's not as simple as this one, right? In the first quadrant, it's easy. We don't have to do any clever adjusting. This measure of the triangle is exactly the number we want. This is the right answer. Okay? So when you push and pull on this box, this is where it's going to end up. Good to know, right? Okay, that is lesson 78. Again, the whole challenge of this lesson is to convert those pictures of those crazy rope things into familiar triangles. After that, all this trig calculations that we've been doing, it's exactly the same. Yay, lesson 78. I hope you feel smart. You should. These are really difficult. Thank you. Goodbye.